This is the first of 12 digital labs. These are digital labs to accompany Schaum's Outlines, Digital Principles, 3rd edition. So in lab number 1, we're going to be looking at numbers used in digital electronics. Now every single lab that you come to, you're expected to bring your parts kit, which are handed out in week number 3. You're also expected to have a copy of the lab printed out, ready to go, and to bring your textbook with you. The required textbook is Schaum's Outlines, Digital Principles, 3rd edition. So this is an example of what your textbook looks like. It's labeled Schaum's Outlines, Digital Principles, 3rd edition. This is the ISBN number, so if you want to order it online, you can. And you notice it's only about $22. So you notice your textbook has a table of contents. The first lab covers the first 2 chapters of the textbook. And as we go further along in your textbook, a lab will be associated with certain chapters in your textbook. So it's very important that you have a copy of this textbook, because all the answers can be found in your textbook. I want you to notice on your labs, I always put a reference section, so I don't pick out whole chapters. So I tell you it's chapter 1, and these are the important parts. So it's 1-1, 1-2, 1-3, and 1-4. And in chapter 2, it's 2-1, 2-2, and 2-4. Those are the sections you need to read before you come to lab so that you can understand what the lab is about. I also put in solved problems. So when you're working on this lab, you should be able to answer solved problems 1.1 through to 1.50, 2.1 through to 2.9, 220, 21, 25, 30, and 33, and 40. I don't expect you to be able to answer every question in the book, but these are the questions that are relevant to the lab that we are doing. So looking in your textbook, we can see that section 1-1 is an introduction to numbers used in digital electronics. Section 1-2 talks about binary numbers, and you can see figure 1-1 talks about counting in binary and decimal. Section 1-3 is about hexadecimal numbers, and you can see in figure 1-7 they're counting in decimal, binary, and hexadecimal numbering systems. Section 1-4 talks about 2's complement numbers, and figure 1-11 talks about 2's complement representation of positive and negative numbers. Moving on to chapter 2, 2-1 gives you an introduction to binary codes. Section 2-2 talks about weighted binary codes, and in this case you can see in figure 2-1 they talk about the 8421 BCD code. And finally, section 2-4 talks about alphanumeric codes. In this case, we're interested in the ASCII code. And figure 2-11 gives us alphanumeric codes in a table. So you can see that every letter of the alphabet is represented by a code. So on this table, you can see that the character, which would be from a keyboard or displayed on the screen, so a character such as the space character actually has an ASCII code, and this is written in binary as 010, 0000, which equates to 20 in hex, and converting that to a decimal number, that would be 32. So the number 32 in decimal represents the space character both on a keyboard and displayed on your computer monitor. So you can see every key that you would see on your keyboard, even the numbers 0 through 9, have an ASCII code associated with them. The characters A through Z These are the capital letters A through Z, have a code associated with them. The lowercase a through Z would have a totally different code, and it's not shown in this table on your textbook. The objective of this lab is to become familiar with the numbering systems used in digital systems, notably decimal, binary, hexadecimal, binary coded decimal, weighted binary codes, and the alphanumeric codes, specifically the ASCII, or American Standard Code for Information Interchange. So if you don't know any of these, then you really need to check out the reference sections because they explain it to you in great detail. If I give you a theory overview, it's actually a simplified version of what's covered in your textbook to kind of help give you a nudge in the right direction in filling in these labs. Now I've given you a couple of tables that we can look at on the first page. In the left-hand column, I've given you decimal numbers, so 0, 1, 2, 3, 4, 5, 9, 10, 15, 16, up to 31. Those are our regular decimal numbers that we should all be familiar with. On the right-hand column, we have hexadecimal, which is made up of two words, hex and decimal. You'll notice in the decimal numbering system, we go from 0 to 9, and after 9, or you can think of it as adding 1 to 9 produces 10. 10 is really 0, carry the 1. So 10 is actually the 11th number in our numbering system. So 0 through 9 are the 10 numbers that make up the decimal system. In the hexadecimal system, hex being 6, decimal being 10. So we go 0 through to 9, and then the next number after 9 is A. So we have A, B, C, D, E, and F, which makes up the hex part of hexadecimal. F is actually 15 because our numbering system starts at the number 0. So after F, or think of it as adding 1 to F, the next number in the hexadecimal numbering system will be 10. Please make sure that you do not call it 10 because 10 is part of the decimal numbering system. In the hexadecimal numbering system, we would say it's 10. In the center, I show you the binary numbering system, and in binary we only go up to the number 1. So we start our count at 0, the next count is 1, and if you add 1 to 1, you end up with 0, carry the 1. So you can see that F in hexadecimal is the binary count 1111 and is also the decimal number 15. So you'll notice in the theory overview I have in here to tell these numbers apart. 10 in decimal is 10, and you can see it's to the base of 10, but in the base 10 numbering system it is usually left off. So normally in decimal you'll just see the number 10. In the hexadecimal numbering system, or hex system, you'll notice it's 10 to the base of 16, or 10 with an H beside it, or you might see it written as 0x10. In binary, we usually use the smaller number 2, Or you may see it written as 0B00000010. Binary numbers are usually written as groups of 8 bits or more. So typically you'll see 8-bit binary numbers, where a bit is defined as being a 0 or a 1. So all my labs come with procedures to follow. And you can see for procedure part A, we're to convert the following numbers from binary to decimal. So you can see these are all binary numbers. And if you take a look at figure 1-2 in your textbook, you should be able to get an idea of how to do the conversion from binary to decimal. So when we take a look at figure 1-2 in our textbook, we're looking at A part, and they're doing a binary to decimal conversion, which is what we're doing in procedure part A. And you'll notice the example is 10011, and they're converting this to decimal, and they're coming up with an answer of 19. So you can see that when we do a lab, it is extremely important for you to have your textbook available so that you can reference it as needed. So under procedure part B, we're going to convert the following numbers from decimal to binary. So you can see those are decimal numbers. And figure 1-4 will tell us how to perform that operation. So in your textbook, figure 1-4 shows you an example of decimal to binary conversion. Under procedure part C, we're to convert the following numbers from hex, that's hexadecimal, to decimal. And check out figure 1-8 for a procedure on how to convert from hexadecimal to decimal. So in your textbook, figure 1-8, and we're looking at A part where they're doing a hexadecimal to decimal conversion. They're trying to convert the hexadecimal number 2b6 to its decimal equivalent, which works out to be 694 in base 10. Under procedure part D, we're going to convert the following numbers from decimal to hex, that's hexadecimal, and figure 1-9 in your textbook should help you do that. So figure 1-9 in your textbook, we are really looking at part A, and that shows us a decimal to hexadecimal conversion. So under procedure, part E, we're going to convert the following numbers from signed decimal to 2's complement. And in your textbook, figure 1-12 should help you accomplish this. So figure 1-12 in your textbook shows you an example of converting a signed decimal number to a 2's complement number. To fully understand figure 1-12, you really need to review section 1-4 on 2's complements numbers. Under section 1-4, they show you the individual steps necessary to do the conversion from signed decimal to 2's complement. Under procedure, part F, we're going to convert the following numbers from 2's complement to signed decimal. And in this case, figure 1-13 in your textbook will help you perform this conversion. So in your textbook, figure 1-13 gives you an example of converting a 2's complement number to a signed decimal number. So while figure 1-13 does show you the steps to convert numbers from 2's complement to signed decimal, make sure you have read section 1-4 in your textbook. It's on 2's complement numbers, and they do show you the reverse process and convert 2's complement to a signed decimal number. Under procedure, part G, we're to convert the following numbers from decimal to BCD. And figure 2-2 in your textbook will show you how to do that. So in your textbook, figure 2-2, and we're looking at A part decimal to BCD conversion, and they show you an example of how to do that. So under procedure, part H, we're to convert the following numbers from BCD to decimal, and that also references figure 2-2 in your textbook. So in your textbook, figure 2-2, B part shows you how to do a BCD to decimal conversion. So under procedure, part I, we're to convert the following to ASCII, and figure 2-11 should help us accomplish this. So in your textbook, figure 2-11 gives you alphanumeric codes, and you can see in the table we have the characters in one column and the ASCII binary codes in the other column. On the last page of all my digital labs, I have questions for you to answer and hand in. On lab number 1, I actually have 8 questions for you to answer and hand in. If you are looking for answers to those questions, open your textbook. Now on page 1 of every lab, I show you some hints, and you can see in this case the hints are going to be solve problems 1.1 to 1.50, 2.1 to 2.9, 20, 21, 25, 30, 33, and 40. And most of the times the questions that I ask at the back of the lab are identical to the questions that are in your textbook. That's why it's extremely important that you bring your textbook to every lab. On lab number 1, I have a place for instructor initials. So when you've completed your lab, you'll show it to your instructor and they will initial it during lab time. In the labs that follow, you'll actually have your circuit wired up to your own trainer, and you'll show your circuit working to your instructor, and they'll initial your lab to indicate that it is complete.